Welcome to SUSECON Digital 2020. This is session ID HOL-1111, hands-on installation and configuration of SUSE CaaS with automation. Take you through a little bit of the agenda for today. Keep in mind, this was originally supposed to be a hands-on session. Everyone was going to have a system with lots of memory in it that you'd be able to build your own cluster on KVM virtual machines. That was the original intent. Of course, I know everyone at home probably doesn't have a 32 gigabyte machine to run on, so but if you do, you can actually grab the files. We'll show you later where to get those and try this yourself. So I would urge you to do that. I think you'll find it interesting and useful. But today what we're going to do is we're going to go through some background and other things about how this got started. Some of the goals for what we're trying to accomplish here. Take a look at some of the automation. We'll look at the definitions of a lot of these terms that are flying about. And then we'll go through an extended video portion of this session and actually take a look at deploying this using the automation. So my name is Dwayne Sims. I'm a SUSE sales engineer based in Raleigh, North Carolina. Been with SUSE about 2 years, and I'm lucky enough to get to contribute to things like SUSECON. This is my second one, so I'm happy to be here. Louis Paul was another person who was going to be helping me. He's a SUSE cloud architect, absolute expert at the cloud application platform. He came over to SUSE from Staccato. And he is, like I say, just an expert at actually deploying applications into the cloud, and especially with the cloud application platform. And we were going to tag team on this session, but I'll be doing the digital version of it today. So why did I create this session in the beginning anyway? What was the impetus behind doing all of this? Well, it was based on frustration of trying to figure out what hardware or what cloud resources to try to set up the SUSE CaaS platform. And we'll talk more about what that is here in just a second. But I was frustrated that I couldn't seem to find a way to do this and actually get a working cluster that I could do things with. I could tie into different kinds of Kubernetes at different places, and I could learn different things about them, but I actually wanted to use our own Kubernetes, our CaaS platform, to do some of these things with. And so I didn't really have a way of doing that, and that was where I guess the sand in the oyster that creates the pearl. Hopefully, this is a pearl that came out of that process. I do want to give some attribution here, though. Brent Griggs from the SUSE Services team built the first version of this, and I've sort of picked it up and ran with it since he actually created it. He actually demoed it. I saw it demoed in 2018 in November, and he had done this for CaaS version 3. So I've since then sort of taken the reins of this, or at least maybe I should say I forked it, to go off and actually deal with CaaS version 4, which was pretty different in the way that it installed. And that's actually at the point where I really started adding the automation to the process. And so, but Brent gets all the credit for doing the first version of this, and basically the concepts around what it does were all I will give him the credit for, because he came up with the ideas behind the aliases and being able to fire off the virtual machines in a real easy way. So got to give Brent all the credit here. So what are we going to try to do? Well, one of the things we want to try to do is understand the automation, because the automation could be applied to other things you might be working on. So if you understand what's going on, you can see how easy it is to script some of this stuff, especially in KVM, and to be able to stand things up very quickly. We want to build a working Kubernetes cluster using the automation that we've described. We want to do some basic things with the cluster. We want to actually do some things like tie in storage. We want to be able to tie in networking. We want to have a real working cluster. And then we'll run a couple of applications in the cluster just so you can see that it really does function. And the idea wasn't originally, if you were going to do this hands-on, was to tear it all down and build it again. So if the automation's working, I should be able to just blow it away and start over. And that is the case for me. I have this installed on my laptop, and way too often I mess things up, or I do something strange and I make a mistake and I get myself fouled up. And rather than fix the foul up, I just tear it all down and start over, because I can use this automation to build a working Kubernetes cluster on my laptop in about 20 minutes. That's about how long it takes. And really, most of that 20 minutes, it's sitting there doing its own thing. I don't even have to tend to it. It makes you lazy in a way once you got it set up, because it's not worth trying to figure out what kind of strange thing you may have done to break the cluster. It's like, I'm just not going to do this. I'll just tear it down and start over. And because it's so easy to get back to a working state pretty quickly. So that's what I do with it. So the automation, what is the goal behind the automation? To build a working CaaS cluster and not have to do hardly any hands-on. Now there's a few places we have to stop and maybe type one more command at times. You'll see that happen in a few places, but we've tried to make that easy to do. And we'll explain later why we had to break these things into a couple of chunks. But the automation does work in such a way that most of the time you don't have to click on any buttons or hit any keys on the keyboard to make it happen. Once you've actually got it started, it kind of runs off and does itself. And again, really wanted to be able to do this on a KVM host. The idea was I want to be able to have a working Kubernetes cluster on a laptop that I can carry around and demo when I'm out visiting customers. If I'm going to visit partners, I can do that and show them how to build a CaaS cluster very easily. That was the whole idea behind it. And then I've also been able to extend it to actually demoing other things as well, which has turned out very nicely. Especially, we'll take a look at Stratus in a little bit. That I can demo Stratus about any time because I've got it running on my laptop. So let's talk about some of the definitions here. You'll hear this term CASP used a lot. That is the Container-as-a-Service Platform. It's SUSE's Container-as-a-Service Platform. We're currently on version 4.1 of the CASP system. And what is this? Well, really, this is a fully curated distribution, supported distribution of the Kubernetes system that was originally developed by Google, that is used for container orchestration. This actually implements today Kubernetes 1.16. That's where we're at today on that. And with version 4 of the CaaS platform, we are keeping up with Kubernetes very well. So we're usually right within a version of where they're at. So we're staying up with the upstream projects. This version of CASP, version 4.1, runs on top of SLE 15.1. And if you've seen some of the other sessions here at SUSECON Digital that talks about the modularization of SLE 15, you'll know that this is basically one of the modules that you can actually load into SLE 15 at install time, and that's how you get there. Now, the beauty behind the automation is this all gets selected for you, so you don't have to actually go and pick it. It will go and pick itself, which is really nice. So it kind of creates the containerized Kubernetes systems on the fly as you're building your cluster, so you don't have to actually go and think about how to be able to support that. And did I pick the right option or anything? Because it's going to pick the right option for you. This is all based on the upstream project called Cubic at cubic.opensuse.org. Please go take a look at that. If you want to grab that and use that, you can do that too. But this is actually based on the release version, the supported version of the Container-as-a-Service Platform. You'll also hear the term CAP used quite a bit. CAP. So what is CAP? It stands for the Cloud Application Platform. This is SUSE's Cloud Application Platform. This is an implementation of the Cloud Foundry system. Now, Cloud Foundry is a foundation, and it was a product originally developed by VMware, and then spun off into an open source foundation, of which SUSE is part of. So there are several companies that have actually implemented Cloud Foundry. Pivotal is one of them. IBM's another. And SUSE's, we've done one too. Now, ours is kind of different. Although we're fully Cloud Foundry certified, our implementation, CAP, runs on top of Kubernetes. And so we've actually taken and sort of married the best of both worlds with the CAP product. This runs on practically any Kubernetes. You can run it out on Azure. You can run it at AWS. You can run it at GCP. Really, whatever Kubernetes you want to deploy it on, you can, including CASP, which is a nice thing. So we can actually run CAP on top of CASP. In fact, if you buy CAP, you get a license for CASP as well. So you certainly have the ability to do that. You're also going to hear these terms used, Helm and Tiller. Well, what are Helm and Tiller? Well, Helm is really a package management system for Kubernetes. Helm runs on your client system, and the Tiller portion runs on the Kubernetes cluster. It's really an easy way of installing a lot of applications. These are based off of things called Helm charts that sort of define where you're going to pull all the pieces in. So a developer can actually create a Helm chart that makes it really easy for you to install applications into Kubernetes. I'd urge you to take a look at the website helm.sh. The Metal Load Balancer. Now, the Metal Load Balancer was a new addition to the CASP automation. When I originally started with this on CASP version 3, we didn't actually have the Metal Load Balancer built into this. So when you got done with a cluster in CASP version 3, you had a Kubernetes cluster, but it didn't really work. It didn't do a lot of things. If you try to deploy applications into it, there was no way for those apps to really get a network IP address that you could actually access later. So again, that sort of added to the frustration of what we were seeing there. But once we introduced Metal Load Balancer to the process, this really improved the workability of the Kubernetes cluster. This basically gives simple load balancing for small configurations of Kubernetes, and that's exactly what we have here. It really simplifies a lot of the more complex networking pieces that you typically would use with a full-fledged production level version of Kubernetes. What this does is saves a lot of resources, so I don't have to worry about building extra virtual machines to be load balancers and those kind of things. It really just reduces the overall complexity of the cluster. Again, the idea behind this is to have something that I can mess around with, that I can demo, I can show the ability to how easy it is to install, those kind of things, but I'm not really wanting to build out a full-fledged, working production cluster. So Metal Load Balancer gives me that ability. This really makes it easy for you to assign external IP addresses to services as they come up. So if I want to deploy applications into the cluster, they can actually get IPs, and I can actually interact with them once they're up and running inside Kubernetes. And again, there's the URL for MetalLB, and it's fully incorporated into this automation. Also, let's take a look at Stratos. Stratus is a UI that was originally developed for the Cloud Application Platform, and it was part of that whole system as we released it. And really, SUSE has been the by far the biggest contributor to the whole Stratus application. It's now part of the upstream Cloud Foundry distribution, so and it will really let you tie into any Cloud Foundry implementation. It doesn't have to be CAP. So the APIs are the same as long as it's a certified installation of Cloud Foundry. It should work just fine with any of the ones that are out there. And I've certainly tied it into multiple Cloud Foundry implementations, not just CAP ones. So it works nicely there. One of the things that SUSE is doing is we're also adding to Stratos the ability to manage Kubernetes as well. So you can actually tie this into CaaS, and it's now actually part of the CaaS distribution. So when you get a hold of if you were just buying the CaaS platform, you would get Stratos as well. So it will actually work with both. So you can manage any Cloud Foundry, or you can manage any Kubernetes for that matter. So it's easy to tie either of those endpoints into Stratos. And you're going to see a lot more out of Stratos in the coming months. It keeps improving. You're going to see interesting things like monitoring and just a plethora of new features coming along in Stratos over the coming months. You also hear about the Kubernetes Dashboard. Now, the Kubernetes Dashboard has been around even back in previous versions of CaaS. It's something we've never really officially supported. Almost everyone will pick up and run the Kubernetes Dashboard with their Kubernetes, so it's a very common thing to see get deployed in a Kubernetes cluster. One of the things that's really nice about Stratus makes it really easy to deploy the Kubernetes Dashboard into your Kubernetes. So it makes it really easy to set up. Just about anything that you can do from the command line with Kubernetes, you can also do from the Kubernetes Dashboard, which is the web-based UI. And once we get down to the demo, you'll see us doing a little bit of that. But I urge you to take a look at the Kubernetes Dashboard and how easy it is to set up once you're running inside Stratos. So what are we trying to do here? What's the overall goal? What we want to do is build a working 3-node Kubernetes cluster on KVM. So you have to have a KVM host to run this on. The host that I'm going to be running it on today is OpenSUSE. I would suspect it would run on just about any system that can do KVM. I haven't tried it on anything other than SLES. I've run it also on SLES. In fact, it was mostly developed on top of SLES, and then I ported it over to OpenSUSE for the SUSECON session. But what we're going to be building is one Kubernetes master. Again, in a production environment, you would not want to have one master. You'd really want to have 3. And we're going to have 2 Kubernetes workers, and typically you would have at least 3 of those in a production system. But we'll have a working system that you can actually play with and do some fun things with by having 1 master and 2 workers. The automation is also set up so that if you need more workers, you can actually build them. So the possibility of actually adding workers 3 and 4 are there. We'll not try to do that today, just in the instance of time, because it does take a little bit more time to build the extra 2 nodes, but certainly can do it, and the automation actually can handle building out 1 Kubernetes master and up to 4 worker nodes. At least given the memory that most laptops have today and most systems that you would be using for demos like this, probably that's about as max as you'd want to go anyway. You're also going to need an admin node to run the CASP automation from. The installation piece needs to run someplace, and there's an admin node that's actually part of this system. Now, originally, when this was going to be a hands-on session, we were the whole package that we were building up that the students would start out on would already have the admin node running, and that's actually where I'm going to start from today. When you actually see this demoed, where the admin node is already going to be built, but we also have the automation there to build the admin node as well. So the pieces are actually there to do that, and we'll point those out later as we go through the process. Also, the nodes are all connected by a private virtual network that's called CaaS.net. This actually gets set up inside KVM. It will also define all the DHCP services for the network. So as the nodes actually come up in CaaS.net, they get their IP address from the DHCP service that's part of the virtual network. So that makes it really nice that I don't have to go and assign IP addresses or worry about trying to configure that into the Kubernetes nodes as they come up. They just get their assignments and go off and are ready to actually operate. Makes the process really a lot easier. And again, I give that attribution back to Brent Griggs, who actually came up with this whole thing originally. And this is a piece that he built, and I really haven't touched it a whole lot. I've had to make a couple of tweaks to it here and there, but this part is a lot left over from the original automation that I got a hold of. Where can I get a hold of this if I actually want to try it myself? Well, of course, everything we do is open source. That's the SUSE way that we do in everything. All the source is out on GitLab, and I've given you the URL there. If you want to go grab it, please feel free to grab it. If you've got ideas later on, you would like to make changes or do those kind of things, please just contact me, and we'll work those in as you come up with them. Happy to have more eyes on this. So here's a little area where I want to try to describe what's actually going on with the automation. The automation is mostly based on AutoYast, and we're actually have a couple of AutoYast files that we're actually setting up. So the KVM host typically is going to provide two different things for us. It's going to be the NFS server for the Kubernetes cluster to actually provide storage to the Kubernetes cluster. And then it also will actually serve up by NFS the AutoYast files. Now you're going to notice that today we had to change this slightly for the automation that we were going to do for the class. So actually I moved the NFS services to the admin node. And this kind of creates a little bit of a chicken and egg problem because well, how would I build an admin node if I don't have the automation to build it? I had to actually build it separately and then moved it into this arrangement. But I would say most of the time you'll use your KVM host for the NFS server for serving up the AutoYast files and the NFS server for the Kubernetes storage. So it will actually take on both roles. So AutoYast, there are two AutoYast files that are actually included with this system. There's one called admin AutoYast, and if you look at the admin AutoYast file, that actually lets you set up a complete admin system. It basically will do this with SLE 15.SP1. And then there's also just an AutoYast file that really defines how I set up the individual nodes for the Kubernetes cluster. If you go and grab this later, I would urge you to go in. You need to make a few modifications to both of these files. One is you need a registration code and a login email for SUSE Customer Center. You would put that in there, and they're pretty well marked in there, I believe, that where you need to stick this at. You might also want to add a password, a hash, and again, the instructions that you would pull down off of GitLab will actually explain how to actually build that password hash. This really just saves you a lot of time of having to type passwords all over the place, which I get really tired of. I can just go ahead and put the password hash into the AutoYas file, and then it's already there. I don't have to worry about typing the passwords all the time. Also, there are places in there to actually stick your SSH keys. Urge you to do that as well, because that will actually keep you from having to log on at all. And really, for the CaaS installation processes, it's going to assume you've already done that. So if you stick this into your AutoYas file, especially as the nodes get built, you don't have to worry about doing all this the key management later on. It'll all be taken care of for you as the nodes get built. So this is a really important thing to do. Also, you're going to run into a script out there called CASP-inst-rc. Again, this was one of those files that was left over from the original version of this. And this script basically defines a whole bunch of aliases. And these aliases are actually used to create the admin and the Kubernetes nodes. It also interacts with the CASP-net and actually defines the MAC addresses, so that as I build the nodes, they wind up with a specific MAC address that will then allow you to tie and pull in an IP address for that node as you build it. If you look at the README, you'll see how that you source this file, this CASP-inst-rc. You might want to make some modifications to it depending on your memory situation. You might want to make the VM smaller. The defaults will work for just about everyone. You'll see there's an alias for install master, and it creates that virtual machine, and then you'll see other ones actually for the worker nodes as well. But the idea is, once you type these commands, these aliases, they build the VMs for you, and you don't have to type anything else or click on anything else. The whole idea is it pulls all that information out of the AutoYas file, and it's completely hands-off. Other scripts you're going to see out there. You'll see another script out there called new admin. Well, what this does is if I've actually created an admin node, if I've just created one, well, how do I get that set up? And how do I get all those scripts out there that I need for later on when I'm doing my install? That's what new admin does. So basically, the new admin will go out there and set up a newly created virtual machine that's going to be used for your admin. It will copy all the keys and all the scripts that are needed out to the admin node. You're going to see another cluster or another script used, and this will actually get copied out to the admin node, and that's called build cluster. Well, build cluster basically goes and will run all of the SCUBA commands. Now, SCUBA are the actual commands that are used to set up the CaaS cluster, but build cluster will run all those for you. Build cluster can be given a parameter or not. If you do build cluster by itself, it's going to assume that you have one master and two workers. But if you say build cluster and give it a parameter of 4, it will actually say, oh, you're going to try to do this with 4 worker nodes. If you do build cluster 3, it will assume you're going to do 3 worker nodes. If you just say build cluster, it assumes you have 2. And again, we're just going to run build cluster by itself here today, because that's how many worker nodes we're going to build into this cluster off the bat for this instance anyway. And again, it just hides all the SCUBA commands and makes it so that I don't have to type them all in. So I just run, once I get the nodes built, I get over to the admin node, I type build cluster, and I go do something else while it's actually configuring and setting up the cluster for me. The next script that you're going to see and you're going to run out there is something called config cluster. Now, you might say, well, why didn't you just build all the stuff in config cluster into build cluster? Well, I could have done that, but the problem is that once build cluster runs, it's really a good idea to let the cluster settle down a little bit, I guess is the best thing to say, before you actually try to configure it. Usually takes, at least on the hardware that I've used, usually takes about 2 or 3 minutes to let all that work sort of finish. So I typically will run build cluster first. Well, I always run build cluster first. And then I wait a couple of minutes and then I run config cluster. And that actually finishes the whole process. And lets the cluster sort of settle down by breaking this into two steps. So what does config cluster do? Config cluster is going to go ahead and install Helm and Tiller into the cluster. It's going to install Metal LB for you, as we talked about before. It's also going to install the NFS client. And again, that's going to come in via a Helm chart so that you can actually use the NFS server. Now again, typically we're going to use the KVM host. If you notice today, it's actually going to be using the admin node as an NFS server. So it could do that as well. And you could, if you have another NFS server that you want to use, if you have an external NFS server that you want to use, as long as you can get to it through an IP address, you could use other NFS servers as well. I haven't actually tried to do that, but I don't see why it wouldn't work. It's also going to install Stratus for you. And again, that's via a Helm chart. So that gives you easy access to the Kubernetes dashboard later on. So you get to take a look at Stratus as well. And then we're going to run some apps in the Kubernetes cluster. Again, the first of those apps is Stratus. And so once Stratus is installed by config cluster, we'll be able to log onto it, get it configured and set up. You'll see that process, and we'll demo that for you. One of the other things that that you're going to see in the demo is actually running Nginx. So this is really just a simple demo, just to kind of prove to ourselves that everything is working with the Kubernetes cluster. Is really a simple demo of actually just deploying a web server into a container. This will actually get deployed. We'll walk through that process. Again, it's well described in the README as well. Also in the README, you'll see the description there for installing Microsoft SQL Server. And the idea behind this is, had this been a working, a real hands-on lab, this was going to kind of be a bonus material for folks that actually got everything done at the end. If you got done quickly and early, this would be something bonus that you would do. Again, the instructions walk you through the process of installing SQL Server, running in Linux, of course, in a container in your Kubernetes cluster. And that's kind of fun to do. Well, so given all of that, let's go ahead and get started. And I'll see you at the as the demo gets rolling. Thanks. All right, let's take a look at using the environment to build a CaaS 4 cluster using the automation that we've set up. You'll notice here we're running as root, and one of the things we want to do is take a look at this, the tools that we've got here. The really interesting stuff is in CASP inst rc.sh, so we're going to source that. And that actually sets up a bunch of aliases for us, makes a bunch of definitions for things that we'll actually use when we're building this. So let's go ahead and we'll get this started because it does take a few minutes to run. So we'll go ahead and have it build the first node of the cluster. And now we've got our first one kicked off there. We'll now go ahead and have it kick off the second, or the first worker node, the second machine in the cluster. Install worker 1. Now that's underway. And now we can go ahead and install worker 2. So now we've got all three of these cluster machines running, and install starting on all three. So let's take a look at some of the automation involved. If we go back and take a quick look, we can see this is the alias for the install master command. So we're doing, we're defining a whole bunch of things here that are happening. Part of what this does is actually uses AutoYAST, and AutoYAST files are being served off of this machine that's running over here that's called the CASP C4 admin. And you can see that running right here. We're going to be using that quite a bit. That's actually the admin node that we're going to actually use to build the cluster with. So that's a virtual machine we've already set up and it's already running. And it's also acting as two things. One, it's the AutoYAS server for NFS, and it's also the NFS server for the cluster that we're going to build. It's actually going to provide storage to the cluster via NFS. So it's serving several different functions there. But you'll notice here that we're actually using the AYAST NF host that we've got defined right here. That's defined in that script that we just sourced, and that's actually pointing to the CaaS, the C4 admin node, and that's the one that we're actually using. And so let's go and take a look at one of these AutoYAS files so we can see some of the interesting things that are in there. Again, most of the interesting stuff's toward the bottom, but this is the thing that's defining all the stuff that's actually going on in the AutoYAS file, or the install that's happening right now. Now, the one that I'm using has already been filled out, but this is the one that's included. If you pull this off of GitLab, this is the file you would see. You'll notice here there's several things that we ask you to install here. The general user for your KVM host would be a good thing to put in here with your authorized keys. The keys that you're using for the /C4 admin would also be good to put in here. And again, this is all documented pretty well if you look at the docs that we're talking about. Also, you need to supply, assuming that you're actually going to go out to SUSE Customer Center to get the updates for this. You need your email address that's registered at SUSE Customer Center, and you need a reg code. Now, the reg code that we're using today is actually a 60-day trial version, and that works just fine. You can go out and sign up for your own 60-day trial version. And if you have a permanent subscription, that's great too. You could stick that in here. So we're actually sticking that in two different places here, one for CASP and then one for basically for SLES, because SLES allows you, or that reg code allows you to install SLES as well. So those are some of the modifications you need to make to your AutoYAS file. But the beauty of this is once you get this done, you don't have to make any more changes. And I don't have to touch the install once it's started. So these three nodes are actually building now. We can take a look at that, and we've got our installs underway. We've got our master node, we've got worker 1 and worker 2. So we'll go ahead and let this run here for a few minutes, and we'll speed this up. You don't probably care to see all this install happening, and we'll come back when the installs are complete. Thanks. And you can see now that our installs are finishing up, and we should be ready to move on to the next step, which is the part where we're actually going to be building the cluster. So we'll go ahead and let this finish. We'll get ready for the next step. You can now see that our 3 worker nodes are master, and our 2 worker nodes have completed installation. So those are all running. You can see here for worker 1, he's been assigned an IP address of 172.25.0.122. That is an IP address that's in this network called CaaS.net. If I go over here to KVM and take a look at the details, I can see that network right here that's defined called CaaS.net. That's actually set up in a configuration file, and we're actually doing the DHCP from in there as well. So that's how each one of these Kubernetes nodes actually gets its IP address. This sort of really helps with the automation so that I can build the same thing every time. CaaS worker 2, 172.25.0.123, and the CaaS master 172.25.0.121. And again, they're all picking those IP addresses up from DHCP that's defined for CaaS.net. Hope that helps. Thanks. Okay, now for the next step in the cluster building process, let's go ahead and take a look at our C4 admin node. And we're going to go ahead and log on there to the C4 admin node. We're going to log in as SLES. That is the account that the CASP installation wants to use, and that's what we've actually set up in our AutoYAS files as well, so that the proper keys are moved into the right places. So we've gone ahead and we're logged onto the C4 admin node. If we take a look here, you can see what the directory structure here looks like that's been built out on the C4 admin node. If I look in the bin directory and just do an ls there of bin, I'll see 2 scripts, and those 2 scripts are part of the package that we put together: build cluster and config cluster. Build cluster actually installs CASP, installs Kubernetes on the cluster, on the master and the worker nodes. It's broken into 2 parts, build cluster and config cluster, because you really want to let the build complete first before you try to do the configuration. You need to let that build settle down a little bit before you try to configure it. It's just very busy, and especially on when you're running on KVM machines on a smaller system, it needs some time to kind of settle down. So that's why it's broken into two separate scripts. So we'll execute those separately. So let's go ahead first, and we'll actually execute the build cluster script. And we'll see here, the first thing it asks is, notice that we already had a configuration here built before, and it's just asking if you want to erase that, and we do. In most cases you would want to as you're building a clean cluster. So now we're going through the process. The build cluster script actually calls a command called scuba. And scuba is actually a wrapper around another set of tools. It's called kubedm. Scuba makes it easier to add nodes, delete nodes, add masters, initialize the cluster from the beginning. It takes care of a lot of the hard things for you. And so I would urge you to take a look at the build cluster script and take a look and see what all the fun things that are in there that it does. But that's what the build cluster script does. We'll go ahead and let the build cluster script run here for a few minutes. It takes a few minutes to actually build all 3 nodes into the cluster. So we'll stop, take a breath, and we'll not force you to sit through all of this. We'll speed it up, so we'll move on to the next step. Is just about finished now. It's actually adding the worker 2 node to the cluster, and we'll see now that we're finished. You can see that we've got SUSE Linux Enterprise running on all 3 of the nodes. Tells me the kernel version. I can tell what version of Kubernetes I'm running, which is 1.16.2, and I can also see what the cryo runtime is. That's the runtime engine that your containers will actually execute in. The cryo version is 1.16.1. So the cluster is completed. It's actually built. We just now need to let it settle down before we run that second script, which is called config cluster. If I look up here at the virtual machine manager, I can actually see my nodes are still very busy doing things after this install. So we'll go ahead and let this guy settle down before we move on to the next step. Okay, now we're ready for the last step in the setup of the Kubernetes cluster, and that is the script that we mentioned before called config cluster. So let's take a quick look at config cluster first before we execute it, so we'll get an idea of what we're doing here. Basically, in the beginning, what we're doing is we're just actually getting some status back out of the cluster just to make sure everything's okay, kind of showing you what the configuration looks like. Then we're actually installing Helm and Tiller. Tillers actually gets installed on the Kubernetes cluster side, and we'll go ahead and do that. That's what's actually happened there. We're also creating a service account to use with Tiller. Tiller is basically a package management system for Kubernetes. It lets you install things relatively easy, and that's a good thing. We're going to be taking advantage of that with some of the other things we're going to do. So again, kind of in the spirit of we were doing before, we do a sleep for 120 seconds just to give Tiller a chance to settle down once it's been installed, so that when we can actually start using it. The next step, we're going to install the Metal Load Balancer, and this is a very simple networking load balancer for systems like this that have a single master. Kubernetes wants to use a load balancer of some kind, so Metal LB basically kind of fools Kubernetes into thinking that it has a load balancer. And so we're going to take advantage of that, and then that will allow us to actually assign external IP addresses to the containers that we're creating so that you can actually interact with them. Makes it a lot more fun. The next thing we're going to do is we're going to install NFS as a service class or as a storage class, and we're actually going to use the C4 admin server as the NFS server. So we've actually got that set up over there, and we fixed it so that the C store path on the admin server has enough space there to allow us to build persistent volume claims that we're going to need in some of the other things that we're going to install. So dropping on down, once we've got the NFS set up, we've got the storage set up. Now we're going to install something that probably everyone wants to see, which is basically a graphical user interface. I want some way to interact with my Kubernetes cluster in a way that allows me to see what's going on and not have to type lots and lots of terse commands. Although you still can type the terse commands if you like, you might find that the Stratus console is a better way to do that. And so that's the next thing that actually happens here is we install the Stratus console. Now the fun thing about the Stratus console is we're going to take advantage of all those things that we've installed before. We're going to use Tiller to actually install the containers for the Stratus cluster or the Stratus UI. We're also going to take advantage of the storage for persistent volume claims because there's databases and other things involved with Stratus that need to run. And we're also going to get a IP address from Metal LB. So that will actually allow us to actually interact with Stratus once it's installed. So we'll go ahead and pop out of here and go ahead and run config cluster. And so first thing we do is we've gotten to the place we've installed Tiller. And that's actually happening right now. So it's going to set for 2 minutes and wait for that to get all worked out. Again, if we were running on bigger hardware or we had actual real servers that we were installing this on, it might run a little faster, but on more modest hardware, it's probably better to let it settle down a little bit and get ready. So we'll give it a break here, and we'll come back in just 2 minutes. You can see that the pause has been lifted, and we're continuing on. Now we're down to a place where we've installed Stratus, and Stratus is being set up as containers on the worker nodes. And again, we put a pause in here for this time for 180 seconds, 3 minutes, to allow Stratus to sort of get settled down before we take a final look at it. I'm going to make sure it gets all of its resources assigned in the proper way. so that after this step, you'll be able to go and actually start interacting with the cluster in a meaningful way. So we'll take another break here until this finishes up, and we'll be back. Stratus has been installed and is running. Looks like it's doing really well. You'll also notice here that an external IP has been assigned to it, and again, that's on that network we called CASPnet. So it gets a 172.25.0.230 IP address, and we can actually now interact with that particular IP address. And we'll do that in the next step. Thanks. All right, so now we're going to move into our last bit of configuration, and that is the configuration of Stratus. And by configuring Stratus, we'll get that nice graphical user interface that we can go and look at our cluster, see our working jobs, see the pods that are running out on the Kubernetes cluster that we've installed with CASP. So let's go ahead and we'll just kind of launch right into that. You may recall as we ran config cluster, we were actually installed Stratus, and one of the things we got from that was actually an external IP address, and that's 172.25.0.230. That's the address that Stratus is listening on. So we'll pop up a browser here, and we should be able to go right out and grab that the Stratus console. And if you'll get a message like this, because I haven't installed any real certificates on Stratus. This is just a demo system, of course. So we'll just go ahead and answer the questions here, accept the risk, and continue. And then you'll see here that we're ready to log into Stratus. And since I've been doing it a bunch of times, you can see I've already got the username and password plugged in here. My username and password is admin, and the password is tux. And if you pull this down off of GitLab, that's what you'll get as the default password that has been set up. So we'll go ahead and do that login, and you'll see we get logged right away into the Stratus console. Now the Stratus console doesn't do a whole lot at this point. This is kind of like the first step into getting in. So what I have to do is I have to connect to the endpoint. Now I can go out and actually look and see what kind of endpoints I can actually join up. I got things like Cloud Foundry, so if I was using SUSE CaaS, I could actually tie into a Cloud Foundry endpoint. I can tie into a Kubernetes endpoint. I can tie into Amazon EKS or the Google Kubernetes engine. I can do things like that. But since I'm going to be tying into the Kubernetes cluster we just installed, I've got kind of two choices here. One would be Kubernetes, maybe, or SUSE CaaS Platform. And I can assure you that the SUSE CaaS Platform is the right choice. That's the one that was going to work the best. So first thing I have to do is I have to give this thing a name. So we'll call it C4 test. Is a good name for this endpoint. Now, what endpoint address do I use? Now, this is a little head scratcher here, and I'll show you how to get that address pretty easily. And so we'll just pop this down for right now, and let's go out. We'll grab another window here that's already opened up onto in our system here. We'll go and grab. Grabbing the wrong one. So we'll go out here and take a look. I've actually created a script that's part of the package that's called pull config. Now, pull config will actually give me the information that I need and actually set up the KVM host so that it actually can interact with the Kubernetes cluster. So it'll actually pull the configuration file down, put it in the right spot in .cube, and also bring the give me that endpoint address. So let's go ahead and we'll run pull config. We'll go ahead. We'll say yes here, and you'll see here it goes ahead and does that. And so it actually copies the Kubernetes config file to /temp, so we can get it into Stratus very easily. Also, this address that comes out of cluster status is the endpoint that I want to use in Stratus to actually do that connection. So let me go ahead and copy that. We'll go ahead and pop over here back into Firefox, and we'll drop that in. And so that's the endpoint address, and I can click skip SSL validation for this endpoint, and that works out really well. So we'll go ahead and register the endpoint, and that worked successfully. So now I want to go ahead and connect to it. So I click the checkbox there. And right now, this is where I go out and grab that config file. That just got dropped into /temp, and you can see there I've already been out there looking at that. So I'll go ahead and grab that, and that's a config file I'll use, and I'll use that for my connection. And as you notice here, we connected right up. So we actually have a good connection on this endpoint. So this endpoint, we named it C4 test. And that's actually the Kubernetes cluster that we've got running here in our KVM environment. So one of the other final configuration things that we need to do is to install the Kubernetes Dashboard. The Kubernetes Dashboard can be a little tricky to install. I've done it a few times, and it's I've had some success with it, and sometimes I didn't have so much success with it. But I think you're going to find out that if I do this through Stratus, it's a very easy. So let's go ahead and do that. We'll go out here where we configure that, and I can click on Install Dashboard. That's really all I have to do is click on Install Dashboard, and bang, it's done. It actually goes out to GitHub and pulls that dashboard down and installs it directly. So that piece is done. The second thing I need to do is create a service account, and that service account is actually what lets me log into the dashboard. So we'll go ahead and do that too. We'll get that service account created, and we're all set. So the two pieces of configuration are done. Again, I can go back out here to my endpoints. I can go in here and look, and you'll notice up here at the top I have a button for View the Dashboard. Let's give this a little bit of time to settle down after the install. It's always a good idea to do that. If you get going too fast sometimes on these setups. You'll sometimes go too fast and create a little problem for yourself. So if you let things settle out a little bit, you can save yourself some grief. But let's just take a look at Stratus for a second. We can see some of the things we can tell about the cluster even from this point. I can go and I can look at the number of pods that I've actually got inactive, which is 34. The system should be able to handle 330. I've got no nodes with disk pressure. I've got no nodes with memory pressure. I've got 3 nodes ready. In my case, I've got 1 master and 2 workers. Everybody's got network connections, so this is all looking pretty good. I can go and see the pods that I have available. So one of the things you're going to find that over time is Stratus is going to become a bigger and bigger player in the Kubernetes world. It's going to give you a better and better dashboard to that. The thing that's really neat about Stratus, though, is the fact that I can create as many endpoints as I want. I can tie this into Cloud Foundry endpoints. I can tie it into other Kubernetes endpoints. So I can use this as a single pane of glass to look at lots of different Kubernetes and Cloud Foundry installations. And I can do a lot of things with them. So watch this space. You're going to see more and more fun things appear in this area. So let's go take a look at that Kubernetes dashboard now. So we're loading the Kubernetes dashboard, and I can actually see what's going on out here from the dashboard. At this point, I'm actually pointing at the default namespace. I see the number of pods and replica sets I have running. If I go down here, let's just pull one up for a second. We'll look at Stratos, and you'll see there the number of jobs and the pods that I have running. So I've got one job that completely succeeded. It does that when it actually installs. There was one over here as well. I've got the deployments are actually part of Stratus. I've got the jobs. I can look at the pods that make it up, replica sets, services. So if I go down here and look at this Stratus console UI.ext, that's actually the 172.25.230 that we're actually pointing at to get in here in the first place. I can also see my persistent volume claims. I've got one set up for MariaDB. I've got another one for the encryption key. So that's where it's actually making persistent storage. So each time I come in, I can get back to where I was. And so all the configuration about what's going on in the cluster is stored there. So again, this is Stratus. I urge you to take a look at it, poke around a little bit, and have some fun with it. Thank you. Okay, now it's time for us to have a little fun with our Kubernetes cluster that we built using CaaS 4.1. So let's try to get maybe an Nginx server running that we can actually see and interact with a little bit. So before we start with that, let's execute a few kubectl commands from the command line so we can actually see what's actually going on with the cluster. So I can see right now the only pod that I have running in a default namespace is the NFS client that's actually working with our storage. I can go back and I can look at other things. So if I want to say get pods and look at the ones that are running in the Stratos namespace, I can see more pods running there that I have running that are in various states of running or completed. So I can get a good idea of actually what's happening in that specific namespace. So let's go ahead. We're going to go and create a new namespace. And I've got some of these commands already queued up here so that you don't have to see me type badly. Let's see here. Where did I pop that one at? There we go. We're going to create a new namespace called tester. So that's a very simple kubectl command. Create namespace tester. And so now we have that one we can actually work with, so that as we get ready to go and deploy Nginx, we'll do that into that particular namespace, and we'll go take a look at that in Stratus as well. So let's go back, and we're now going to run this command. This is something we're going to call it hello app. It's going to pull an image called hello out of the Nginx demos registry. It's going to be using port 80. We're going to make 2 replicas. That means we're going to have 2 of these running at the same time, and we'll take a look at that. There's some fun things we can actually do with that later. So, and again, these will be running in the namespace called tester. And so we now see here that our hello app is created and is running. So I can get more information about that if I go back and say describe my deployment here of Hello App, I can actually pull up more information about what's going on. One thing I haven't done yet though is I haven't actually assigned it an IP address, and so that's what I'm going to do next. Is I'm going to go back and do that, and we do that with the kube control command called expose. So we're going to expose this deployment again, and we're going to tell it to actually use the load balancer that we've set up with MetalLB to actually assign an IP address. And again, we're going to do that in the namespace called tester. And so we now have actually done that. So if I do kubectl, let's see, get svc-n tester, I should get the load balanced IP address, and I can actually see that right there as the external IP for this particular deployment. It's 172.25.0.231. So if I come back down here to my browser, and let's say we go ahead and stick that in, 172.25.0.231, I will actually hit that little web server that's running in that container. And you can see here that it gives me the server name, and that will be interesting in a little bit when we actually go and look and see what's actually going on with that. So let's actually log back into Stratus. We still got our endpoint defined as we've done before, so we can pop into there, and we can see that we've got nodes that are being used. We've got 3 nodes ready, nodes available with network. We're looking good here. We can go back into the dashboard, and when we go back into the dashboard, I can actually go and look at a specific namespace. There's my tester namespace, and I can see that Hello App is running here, and it's actually got 2 pods that have been created. I can see both of those, and if I go and look, I can see that this one had the end of it's called KT or KTHRJ, and so if I go back over here, I'll see one of these as KTHRJ. So when we actually hit that, we were actually talking to worker 1, the container that was running on worker 1. I can go down here and see that this is set up as a replica set. The service, again, was defined as the external endpoint here that was assigned by MetalLB, was 172.25.0.231 running on port 80. So I can see all of that, and it's all running there nicely and everything. Now let's do something fun. Let's go and say this container that's running on worker 1, I can actually go and kill that. So let's delete that pod and make it go away. So it should exit at this point. And there he goes. He's dying. Terminated, completed. Now if I go back over here and I refresh my screen, we've actually switched. We are now running on BQ7N2. So if I go back over here to Stratus and look, do I have one of these? It's called BQ7N2. Now we hit the one back on worker 1 again, which is interesting. So the Kubernetes actually restarted Nginx, and actually he restarted on worker 1. By the time we actually got to the point of refreshing, we actually got the one that just came back up. So it's just a question in the load balancing world of which one you hit. But that's an interesting thing to see and some of the power of Kubernetes to restart things if they could die. If there's a reason something falls over, Kubernetes will restart it automatically and get you back up and running. So he always keeps the number of replicas that you've actually specified. If you remember when we did this, when we actually started this up, if we go back and look, we actually asked for 2 replicas. I could have asked for 3 replicas, and I would get 3 of these running. So just some of the power of Kubernetes and some of the fun things that it can do. So let's go take one more look at Stratus here. Let's go ahead and sort of clean up after ourselves, and we can, again, looking in this thing, we can actually delete this deployment completely. So we can go and do a delete here, and we'll clean up after ourselves in the little demo that we just created. And you'll see here that all the pods get destroyed. You will still be left with the service. The service would still be assigned, so if you actually came back, you could reassign that. but we'll go ahead and delete that too. And that will go away now. And so that should be all clear. And then I can even back up to another area here. I can go to namespaces, and I can delete that namespace that I set up called tester, and that can go away as well. Okay, hope you've enjoyed seeing this quick demo here of Nginx running in a container. Well, thanks for joining me today for HOL-1111 at SUSECON 2020. If you'd like to try this automation of CaaS 4.1 yourself, please be sure to see the following URL on GitLab, and you can clone this yourself and give it a try. Thank you very much.